In working with an Oracle database, it is useful to understand a little bit about the context in which an Oracle database operates with respect to other application tiers. Today, most line of business applications are developed as web applications or make use of some sort of service-oriented architecture. If we think about how these applications or web services are deployed, what we probably have is some sort of cluster of servers, and each server is running a copy of the application, whether that be a web application or a web service. It doesn't matter if this cluster is composed of physical or virtual servers, the point is that we have multiple servers to handle the load. Having a cluster of servers to run our application like this serves two purposes. First, if one server crashes or has to be taken out of the cluster for maintenance, we have redundancy and our application doesn't go down just because we lost a single server. Second though, our cluster is an example of horizontal scaling. That is, to support more users or more load, rather than a single very powerful server to handle that load, we employ a large number of smaller servers to handle the load. If our load increases, we handle this by adding additional servers into our cluster. At the database tier, the story is different. At least as of today, when I am recording this, generally what we do is engage in vertical scaling. That is, we have a single very powerful machine that serves as the database server. This machine has many times the amount of CPU and memory of any of the servers in our web cluster, and is also connected to some sort of very fast disk, like a storage array network or SAN. If we need to support a higher load, then we upgrade our database server to add additional CPUs, add additional memory, or even expand our storage area network so that the data is distributed across more disks. One of the main reasons for this is that the data in the database has to be consistent. That is, the data has to be in sync, and keeping that data in sync between multiple servers is a very hard problem to solve. Now, Oracle isn't just used as the back-end database for line of business applications that may have some sort of interactive front end. We also have to consider batch applications that run very high volume workloads and need to finish within a specified processing window. And we have business intelligence applications which read and process large amounts of data. The common thread amongst all of these uses, though, is that we usually have a very large, very powerful Oracle server that is used as the back end of these applications. Now, we are starting to see more movement in this area where you are able to build database clusters using multiple servers as opposed to one very large powerful server. But for right now, generally you will see vertical scaling used in the database tier, so you'll have a very powerful machine as your Oracle server. As a result of needing to support a large number of concurrent users and be able to retrieve data for these users in a very efficient fashion, or to support very data-intensive applications like business intelligence applications, Oracle is what you would consider a memory-intensive application. The server that Oracle is running on will have many times the amount of memory that a PC or even a web server has, and Oracle will essentially consume all of the physical memory that is not devoted to the operating system. What is Oracle doing with all of that memory? First of all, Oracle makes extensive use of caching. And secondly, Oracle has to have working areas of memory to perform operations like joins or sorts in order to fulfill the SQL statements that it is processing. So let's look into how Oracle uses this memory in more detail.